What connects coral reefs and kidney stones? Well, quite a lot. In both, dissolved substances react to form a solid product. They both involve a precipitation reaction. So get your goggles on, let's find out more. This is Real Chem. The precipitation reaction precipitating a pretty precipitate. Try saying that 10 times fast. Or the dissolution reaction dissolved the soluble solute. Sorry for my silly soliloquies, but they do help me introduce the language of two important processes in chemistry, processes that are the reverse of one another. Let's explore. If I add some calcium carbonate to water, a small amount of this salt will dissolve. We can write this as a chemical reaction called a dissolution reaction. The S stands for solid, and the AQ stands for aqueous, meaning the chemical species is dissolved in water. So the reaction equation is a concise way to say a solid is dissolving in water. If I reverse this reaction, I get a precipitation reaction. A solid precipitate is being formed from species dissolved in that solution. The fact that these reactions are the reverse of each other allows us to draw some important connections that we can use to understand when precipitation reactions will occur. The key is the solubility of the precipitate. Calcium carbonate is only slightly soluble in water. Only 13 milligrams will dissolve in an entire liter of water. This means that if we try to put more than 13 milligrams into a liter of water, the solution won't be stable. The water is only willing to hold so much calcium carbonate. If we put in too much, solid calcium carbonate will precipitate out until the solution has an amount that water is willing to hold. That means that if we try to put more than 13 milligrams into a liter of water, the solution won't be stable. The water is only willing to hold so much calcium carbonate. If we put in too much, solid calcium carbonate will precipitate until the amount left in solution is an amount that water is willing to hold. So insoluble or slightly soluble substances will precipitate when you get too much of them in a solution. How can we end up with too much in a solution? This can happen when we mix two solutions, one with a lot of calcium and one with a lot of carbonate. When mixed, there is more calcium and carbonate than the water is willing to hold. So calcium and carbonate react to form solid calcium carbonate via the precipitation reaction. This is one way to write a precipitation reaction. It is called the net ionic equation because it focuses in on the net effect of the reaction on the chemical species. The other way includes the spectator ions. Ions that are important only because they keep the solution electrically neutral. They're just spectators to the overall chemistry, like a crowd of spectators watching a contest between calcium and carbonate. We drew our starting solutions as if they contained only calcium ions and carbonate ions. But the solutions must be electrically neutral. If we add chlorine atoms to the calcium solution, we can neutralize the charge. Calcium chloride is a soluble salt, so these ions can stay in solution together fine. Similarly, we can add sodium ions to the carbonate ions because sodium carbonate is a soluble salt. After mixing, the sodium chloride remains in solution because sodium chloride is also a soluble salt. This is another way of writing a precipitation reaction, one that includes the spectator ions. When dealing with precipitation reactions, it's very helpful to be able to go back and forth between these two different representations. Kidney stones are incredibly painful, so I used to hate precipitation reactions. Then I went scuba diving and saw how beautiful the coral reefs are. It's a good reminder to always keep an open mind. So explore and remember to have fun.